Here's an example where we solve a system of two linear equations by substitution. So we've got 3x plus 4y equals 54 and y equals x minus 4. Now when we solve a system of linear equations by substitution, what we're doing is we're basically substituting an expression in for a variable to solve for the other variable. Okay, so if we look right here, this is pretty awesome because the way that this problem has been given to us, it's kind of already been done. We know that y equals x minus 4. So we could theoretically take the expression x minus 4 and substitute it in for y up here, and then we'd end up with an equation with only one variable, and we could solve for that variable. So let's give it a shot. So what I'm going to do is I'm going to take that first equation, 3, and I'll just rewrite it quickly. 3x plus 4y equals 54. And I'm going to take x minus 4 and plug it in for y. So 3x plus 4, and I'll go to blue so you can see this a little better, x minus 4, so plus 4 times the quantity x minus 4, equals 54. Okay, so this is great because y, we already had one of the equations in the form y equals or x equals. We were able to just substitute that expression in for y. We were able to substitute the x minus 4 in for y. So now watch this. We have 3x plus, and then remember, distribute that 4. So 4 times x is 4x, and 4 times negative 4 is negative 16, and that equals 54. All right, so let's add 16 to both sides, and I'm going to do two things at once here too. I'm also going to combine like terms. 3x plus 4x is going to be 7x. Ooh, I don't like the way that was written. Sometimes when I get to the bottom of the thing here, it's hard to write. 7x equals, and then 54 plus 16 is going to be 70. So then to solve for x, divide both sides by 7. And we end up with x equals 10. Boom. Now, if we want to know what y equals, we just have to say, well, we know that y equals x minus 4. So wait a second. We know that x equals 10. So we can just take the 10 and plug it right in there and solve for y. So y equals 10 minus 4. So y equals 6. Boom. There's our answer. Now, if your teacher wants it written as an ordered pair, which sometimes they might write it in the form x comma y. You could write it as 10 comma 6 as an ordered pair, or you could just box your answer, x equals 10, y equals 6, you know what I'm saying, or you could put them together. But we're not done, because if you remember on the graphing ones, I said we need to check our answers. So let's check our answers, because it's always a good idea to make sure we've done it correctly. So we know that x equals 10 and y equals 6, at least that's what we got. So let's check it in equation number 1. So equation number 1 was, if we want to number them too, we can number this 1, we can number this 2, okay? So equation number 1 was 3x plus 4y. So 3x plus 4y equals 54. So we want to know, is that true? So we plug in 10 for x and 6 for y. So 3 times 10 plus 4 times 6, does that equal 54? So 3 times 10 is 30. 4 times 6 is 24. Does that equal 54? It does. 30 plus 24 equals 54. Perfect. All right, let's check it in number 2. So it's y equals x minus 4. So again, x is 10, y is 6. So is it true that 6 equals 10 minus 4? Why, yes it is. 10 minus 4 is 6. 6 equals 6. We are done. All right. So let's do another one, because that one that we just did was nice and easy because everything was kind of set up for us in such a way that it was y equals. And now let's take a look at one where it's not as straightforward. So again, substitution. We basically want to solve for one of the variables and then plug the expression that we get in for that variable in the other equation to solve for that other variable. Okay, so I'll number these again like we did before. Might be helpful. So let's think about it. We either want to solve for x or for y. Now, there's no reason you should try to make your life more difficult and more complicated. Pick the easiest thing to solve for. Okay, pick the easiest thing to solve for. So look at this. I've got a y. I'm going to use it in bright red so you can see. Right here. It's by itself. It has no coefficient. That's phenomenal. Let's solve for y in the first equation. Okay? So I'm going to look at it right here. I've got 4x plus y equals 19. So if I subtract 4x from both sides, I can solve for y. Okay? Subtract 4x from both sides, solve for y. So I know that y equals 19 minus 4x. Okay? Now, what do I do with that? Well, if I know y equals 19 minus 4x, I can take that expression right there, and I can plug it into the second equation for y. And then that way the second equation only has one variable, so I can solve. So I'm going to go to equation number 2, right here, which is 3x minus 2y equals negative 5. And I'm going to take that 19 minus 4x and plug it in for y. And that equals negative 5. Good. So now I'm going to distribute. Now remember here, I always tell my students, think of it as distributing a negative 2. So make this a plus and change that to a negative 2 there, and you're distributing the negative 2 in. So it's going to be 3x, and then negative 2 times 19 is negative 38. So you can do plus negative 38 or you can do minus 38. Okay, and then negative 2 times negative 4 is going to be positive, so plus 8x. Okay, and that equals negative 5, right? So then we can combine like terms, 3x, 8x, that's going to be 11x, minus 38, and that equals negative 5. So then add 38 to both sides, and you end up with 11x equals 33. I'm running out of room here. Divide both sides by 11. So let's just come right up here. And you end up with x equals 3. Perfect. Okay, so now we need to know what y is. Well, think about what we did in our first step. We solved for y right here, okay? So theoretically, we can take this x equaling 3, and plug it in for x over here in this y equals 19 minus 4x and solve for y. So let's do that. So we know that y equals 19 minus 4x, okay? So in this case, x equals 3, so we're going to plug the 3 in for the x. So y equals 19 minus 4 times 3. So that's going to be 19 minus 12, and that's going to equal 7. Boom. So I know that, and if I want to be all organized here, I could write right over here, rewrite it. X equals 3, y equals 7. Boom. Okay. That was great. But what's the one thing we have to do? We need to check our work. Okay, we need to check our work. So let's do it in, I'm going to do it in sort of a gray. Let's see, just to have a different contrast here. So here's our check. Okay, good, that's definitely different. Here's our check. So I'm going to write that we know that x equals 3 and y equals 7. So we're going to plug it into both. So let's see. So here it is in number 1. So 4x plus y, we want to know, does that equal 19? So 4 times 3 plus 7, because x is 3 and y is 7, does that equal 19? And we've got 12 plus 7, does that equal 19? And 12 plus 7 does equal 19. So we're good. All right, so let's check it in equation number 2, which is 3x minus 2y equals negative 5. So let's see if that's true. So again, x is 3, so 3 times 3, minus y is 7, 2 times 7. equals -5. So that's going to be 9 minus 14. Does that equal -5? And 9 minus 14 does equal -5. So we're done, and we're right. So x equals 3, y equals 7. So again, substitution, if it's not written where it's clearly obvious, like one of the equations is y equals something, or one of the equations is x equals something, or if it's different variables, a equals, b equals, you're going to need to solve one of the equations for one of the variables. And the key thing is there is don't try to be a hero, don't try to do something more complicated, just do the easiest thing that you can solve for the variable that's easiest to solve for. So in this case, if you see a variable without a coefficient that's positive, perfect, solve for that one. Nice work.